Hello everyone, today we are diving into the wild world of chi-square tests. Where means are irrelevant, the data is categorical, emphasis on categorical or nominal, and the only thing that matters is whether your variables are, kind of like secretly dating behind your back, or whether they're related to each other. Let's put it this way, let's not confuse stuff. So anyway, welcome to this video about chi-square for association and its cousin, the McNemar Test, also known as chi-square but for clingy paired data. Anyway, grab your variable list and unprocessed caffeine source of choice and let's dive into it. So, up until now, you've probably been living in a cozy little stats bubble filled with t-tests and ANOVAs. Maybe not the coziest things ever, but maybe, let's say, cozy enough, right? Something that you already know at least. So everything there is about means, but what if I told you that not every research question cares about averages? For instance, what if your questions are Sigma males more likely to listen to funk music than Taylor Swift? Or are girls more likely to pick crime dramas over soap operas? Did a career talk actually change anyone's mind about going to uni? So, in this kind of questions, you are not comparing means anymore. You are instead looking for relationships between categories, or relationships, associations between nominal variables. And here is where our chi-square comes to the rescue. So let's say, for instance, we want to know if gender is related to preferred content on YouTube, right? We're serving teens and ask them, so what do you prefer? True crimes, you prefer watching Dota content or League of Legends or something like that, or neither, right? Then you count how many boys and girls pick each one, but now the question is, are these choices randomly distributed, or is gender somehow associated, significantly related to this choice, right? Chi-square in this case will compare what you observed versus what you would expect if the variables were totally unrelated. So here you have a key thing to remember. In chi-square, you want observed and expected scores to be far apart, because this is how you get significance, right? For instance, in something like regression, you actually wanted your observed and predicted values to be close, but in chi-square it's not like that. In chi-square we want the opposite. We want them to be far apart, because if our observed scores are very far away from our expected scores, it means that probably there is a relationship between the two. But as usual, just keep in mind that Jamovi will handle your expected frequencies, your degrees of freedom, your p-values, and existential doubt, kinda, I guess, probably, maybe not, maybe that doesn't do that. But anyway, you will definitely handle expected frequencies, observed frequencies, degrees of freedom, p-values, and all that you need in order to be able to interpret chi-squares and McNemar. I can assure you that. So let's look at this data set that we have read here. This would be for chi-square, and in this test we are trying to see whether there is a significant relationship between gender and content on YouTube, meaning what people watch on YouTube, and probably would make more sense to have here music listen on YouTube, but again, you guys get the point. So as you can see, we have nominal variables because we're doing chi-square, which is basically correlation but with nominal variables. So we change our ones to males, two to females, or whatever else you have on your data set, and we change these other things, still nominal, into whatever thing you have in your data set. Keep in mind, that to change the numbers, you just click here, you will have for instance, if you don't have nothing, you just have 1, you just click on it and you just write the other thing. So that should be it. Now, if we want to do chi-squares, it's gonna be very easy. Nothing as hard as ANOVA, moderation, mediation is super easy. We go to frequencies, which is these 4 cubes over here, kind of like, you know, your IKEA Eckets, I think the name of those things, your IKEA cubes where you put your stuff. And then you go to contingency tables and independent samples, chi-square test of association. Now, for some of you, this might ring a bell, because this is what we did when we were trying to look for relationship between nominal variables without asking if there was a significant relationship between them. Because when we want a contingency table, we will do the same thing. We will just not care about the p-value in it. So we click on it, and most of the time we will not really care what we have in our rows and what we have on our columns. It's just important for us to make sure that we understand where is what. And then what we want to do is to have also the expected counts, because if you remember, we want our observed counts, meaning the numbers that we actually observed in our data sets, to be far away from the expected counts, meaning the counts that we should expect in case of no relationship between the two variables. And why not? I would personally also add percentages of the total, meaning that in this case, for instance, we know that males listening to funk music are constituting the 18% of our sample. Again, just an information that it might come in handy later on. But how do we know if we have a significant relationship? Well, that's pretty easy. We just look at the p-value. If the p-value is less than 0.05, then we do have a significant association between music listened on YouTube and gender. In this case, our p-value is less than 0.001, meaning that it is extremely significant. So yes, there is a significant relationship between music and gender. If we were to report it, we will write chi-square. We will write it, as this, as this Greek letter over here. But I cannot do it on Jamovi right now. But make sure to write this letter over here. You can paste it from Google or something like that. You will write in parentheses the degrees of freedom. In this case is 1. Jamovi gives it for you over here. Then you will write the value of chi-square, in this case is 18. Then you will write the p-value, of course italic, in this case it is less than 0.001. This should not be italic instead. And then you will also write the sample size. In this case the n is italic. And there you go. This is how you will report it in APA style. So based on this, we know that we do have a significant association between the two variables. But we also want to know who is listening to what and something like that, right? Because maybe the hypothesis could be that males listen to, I don't know, Taylor Swift more or something like that, for instance, right? So in this case, you will just check if males actually listen, if more males listen to Taylor Swift or to funk music, and here you have your observed numbers. You know that in your sample, it's a sample of 250 people, you can see it here, but if not, you can just check it in Jamovi and you will see you have 250 participants, and 109 of these participants are males. And as you can see from here, 18% of your sample are males listening to funk music, whereas 25.6% of your sample are males listening to Taylor Swift. Somehow it's more females listening to folk music. Well, who's a sigma now, I guess? Well, again, these data obviously are just fictitious and there is nothing that, it's real. But still, This is how you do your chi-square. In case this p-value is not significant, most of the time, at least in most classes I know, you will not really need to report the contingency table because whatever will appear here will be just due to chance, right? Because p is not significant. So this was it for chi-square. You have two tables, up to two tables, because if the p table is not significant, you don't even need the second. And that is it. Simple as that. But let's do now McNemar just to make sure to also show that we can do two tests in one video, and both of them will still be easier than one ANOVA promised. The McNemar test, it is very similar to chi-square, but it is, as mentioned before, it is for related samples, meaning the same people in different conditions. Kind of like within subjects t-test or related sample t-test or paired sample t-test or ANOVAs, which are paired samples within subjects or something of this. Yes, I know, so many names for the same thing, but yes, what we're basically doing here is a test whether there is a significant association between paired variables, okay? So it is like chi-square, but for related variables, okay? So in this case, McNemar is what you used when you have the same people measured twice and you want to know if something changed, okay? So for example, let's say you ask a group of students whether they want to go to university. Then you give them a motivational talk about higher education and how important it is, and it is important. Study and come to uni, but study. Trust me, best university in the world, for sure in the Czech Republic. And then you ask them again, same students, same question, just now they've been exposed to your weird little PowerPoint about finding your path in life. Yes. You don't care whether 40% or 60% of students said yes overall. What you care about is who changed their answer. That is, the people who went from no to yes or yes to no. In this case, you will go for the ones that changed in your favor. So the one that went from no to yes. The McNemar test is able to isolate those shifts and tells you, was there a meaningful change? Did they actually move people? Or was it just noise? Okay? And in Jamovi, it is again very, very, very easy. We go back to our frequencies, and this time, instead of independent samples, chi-square of test of association, we go to paired samples, which is McNemar test. We click on it, we put the before into the rows, after into columns, but again, there is not really a big difference in this. So, once you have those two tables, once again, it is as we saw before for chi-square. The first table we want to check is this one, where we have our p-value, our degrees of freedom, our chi-square value, and our sample size. Yes? If the p is significant, meaning there was some significant change, then we also check the second table, the one of the contingency tables. Since I like to have my percentages, I will click on the row percentages, and what we have here are the people, what we care about in this case, are the people that went from no, I don't want to go to university, to yes, I want to go to university after the talk. So make sure to check the quadrant. So this is a quadrant, this is a quadrant, this is a quadrant, this is a quadrant over here, this 4 quadrant in this case. Make sure to check the one of those that changed in your favor. So those that went from no before, so we check this row for sure because the before no, to yes after. So this is the quadrant we care about. So we know that in our sample 38.3% of people change their mind when it comes to go to university. And yes, if you want, you can say 59 people instead of 38.3% people. And this is a significant change according to the McNemar test, because P is less than 0.25. And yes, that is it. No trick, no anything. It is this simple. And yes, we can. I mean, yeah, we can do it, obviously. Sorry, I didn't want to sound political. Just I thought it will fit really well. Anyway, that's it. Both are great for categorical data. Both are quick and easy to run in Jamovi. And neither require you to do math by hand, which honestly should be a basic human right by now at this point. It's 2025 and yeah. Anyway, no shades on anyone. That's it. 2 tools, 2 use cases, no formulas, and a lot of potential for statistically valid chaos.